Good morning. And it is a beautiful morning. So thank you all for joining us. I'm Eileen Claussen, President of the Center for Climate and Energy Solutions. Most of you probably know by now that C2ES, as we call ourselves, is the successor to the Pew Center on Global Climate Change. It's a new name. Well, actually, how did I get this kind of note? I mean, it's not a new name. We've been at this for like a year and a half, but it seems new to people, and we keep saying that we were the Pew Center on Global Climate Change. So in case you were wondering, that's us, a newish name, but our core objective remains very much the same. We're interested in advancing practical and effective solutions to our climate and energy challenges. And we believe strongly, and always have, that these twin challenges must be addressed together, and that finding ways to do it is one of the paramount challenges of the 21st century. So we're very pleased this morning to share some new work that highlights opportunities to do just that, to effectively address both energy and climate at the same time. And we're thrilled to have such a fine group of experts to help us explore from a very practical perspective both the opportunities and the obstacles and how we can best overcome them. As I'm sure you're all aware, the United States is in the midst of a natural gas revolution. Through innovative technologies, thanks in part, I would note, to early support from the federal government, the natural gas boom is reconfiguring our energy future. Exactly how, it's hard to say, and like any revolution, the natural gas boom presents both challenges and opportunities. We're reaping some of the potential economic benefits already. The energy sector is adding jobs, and lower natural gas prices are driving new investment in U.S. manufacturing. But the specific opportunity I'd like to focus on today is the opportunity to address climate change. Increased natural gas use is an opportunity to substantially reduce our carbon footprint. U.S. emissions are back at about the same level as in 1995, in part because power companies substituted coal with natural gas. We wanted to know what other opportunities might be out there. We wanted to know, in other words, how we can best leverage our newly abundant natural gas supplies to reduce greenhouse gas emissions across the economy. To answer that question, we teamed up with researchers at the University of Texas at Austin, and we began looking sector by sector. We looked at the opportunities and challenges in power, transportation, manufacturing, and in the building sector. We organized workshops in Houston and Boston to get input from experts from companies, including members of our Business Environmental Leadership Council, from policymakers, from environmental organizations, and from other stakeholders. And along the way, we published a set of background papers. Because we were looking primarily at the end use of the equation, our final report does not address other important issues raised by the natural gas revolution, such as concerns around hydraulic fracturing. What it does do, we believe, is provide the most comprehensive look yet at the potential climate benefits of this historic energy transition. We're really pleased to share our findings with you today, and in a couple of minutes, I'll turn things over to Michael Weber to walk through our conclusions and recommendations sector by sector. But first, I'd like to summarize for you the three key overarching points that emerged from our analysis. The first point is that substituting natural gas for coal and oil can indeed help reduce greenhouse gas emissions in the near term and in the medium term, even as the U.S. economy continues to grow. U.S. emissions are now back down to where they were in the mid-1990s, in part because of the switch from coal to natural gas. They're expected to remain below peak levels for another 30 years, as natural gas continues to substitute for higher carbon energy sources. In every sector we looked at, we saw opportunities to put natural gas to work in ways that reduce our carbon footprint. The second key point, though, is that these near and midterm reductions are not enough for us to meet our long-term goal of addressing climate change. Natural gas is a fossil fuel. Burning it releases greenhouse gases. So we also need zero-emission sources of energy, such as wind, nuclear, and solar. We need to keep pushing on energy efficiency. and we need support to begin deploying carbon capture and storage technologies at power plants burning both coal and natural gas. Third, we need to remember that methane, the main component of natural gas, is itself a potent greenhouse gas. It is really essential that we minimize direct releases of methane into the atmosphere. We need to get a better handle on the full life cycle emissions from natural gas, as it's produced and as it's used, so we can find cost-effective ways to cut emissions along the entire value chain. We have the technologies to reduce these emissions. The challenge now is to make sure that they're deployed. Before closing, I'd like to thank Michael and his colleagues at UT, our partners in this project, and our thanks as well to the American Gas Association and the American Clean Skies Foundation for their generous support. So in short, we believe there are real opportunities here to meaningfully address both our energy and climate challenges. But maximizing these synergies won't happen all on its own. There are things we need to do if we want to see it happen. And here's Michael to tell you more about what they are.
Thanks, Eileen. Good morning, everyone. It turns out there is traffic in Washington, D.C. I don't know if you know that, so I barely got here in time. But I'm sure the locals realize that. A lot of cars in a small amount of space. So there's a lot of carbon emissions. So we have to take carbon emissions from that traffic seriously. It was great to be a part of this report and the study with C2S. I want to thank C2S for the invitation and the opportunity to partner with them, and also thank the sponsors for making this happen. I'm going to go through sector by sector specific recommendations. And again, we focus on the end-use implementation, not the extraction or the distribution of it, which has its own set of issues. And for the most part, I'll summarize by saying natural gas is a big step in the right direction. It's not the final step, but it sure is headed the right way. And so there's a lot of good news around it. In the power sector, one of the main points that fuel diversity is useful and important part of this, and then natural gas plays a role in that. In particular, what we think about with natural gas is it has roughly half the CO2 emissions per unit of energy compared to, say, with coal. Now, that actually is misleading because it's even better than that. If you compare a power plant from coal and a power plant with natural gas, both with the same efficiency, the natural gas has half the carbon emissions of the coal. But if you compare a new natural gas combined cycle power plant with an old coal plant from the 1970s, vintage era, the 1970s coal plant is like a 30% efficiency. The new natural gas combined cycle plant has something like a 40 to 60% efficiency. The carbon benefits are even better. So there's a lot of advantage in switching natural gas from a carbon perspective, also from a mercury, SOx, NOx perspective, and from a water perspective, because the natural gas combined cycle is partly air-cooled. It uses about half the water per kilowatt hour compared to a coal plant. So there's cross-cutting environmental benefits, which is good from a climate perspective and everything else we care about. And one of the things people worry about, I think about, is a competition between natural gas and renewables in the power sector. And we see this in Texas. We have a competitive market in Texas. And at the marginal kilowatt hour, there's a lot of competition between natural gas and wind or natural gas and solar. And I think this competition is a little overblown. And in my perspective, natural gas and renewables are actually quite complementary. And actually, I would say that a lot of the natural gas companies are fighting against renewables, should instead be teaming up with renewables to fight against coal. There are problems with natural gas and problems with renewables, and they both complement each other. The price stability of natural gas is a good hedge for the price volatility. The price stability of renewables is a good hedge for the price volatility of natural gas, and the reliability of natural gas is a good hedge for the variability of wind, say. So they solve each other's problems, which means there's an opportunity there for complementary dispatching and installation and long-term planning. So there's a good opportunity with natural gas, and it's not as bad for renewables or nuclear as people think. In the built environment, there's also opportunity to use natural gas to displace other fuels. For example, we use a lot of fuel oil or heating oil in the Northeast for heating water in homes. That could be done with natural gas instead, which is both cheaper and cleaner if we can get the distribution systems built. There's also an opportunity to replace electricity with natural gas. It turns out that electric water heating, while very efficient at the water heater, inherits the low efficiency of the power plant to make the electricity. So if you replace that electric water heater with a natural gas water heater, your life cycle energy use and carbon emissions are much lower. So replacing electric end-use appliances with natural gas end-use appliances is a step forward and a good way to go. That improves on cost for the consumer and improves on the energetic balances and the environmental trade-offs. There's a challenge there in some places where not every home has natural gas infrastructure or has piping to bring the gas to the home, so that's a policy opportunity. And then one of the things here, so one last comment is consumers need to know about that, need to know more about their choices. Moving on to manufacturing, there's a great opportunity in manufacturing. Low-price natural gas is a opportunity to launch a chemicals-based manufacturing sector that uses natural gas as the feedstock instead of petroleum. Cheap natural gas has kicked off what's been announced to be something like $100 billion of investment in the chemical manufacturing industry in the U.S. So after a decade of watching offshoring as companies and industries have gone to other places to get access to cheaper gas, we're now watching inshoring or onshoring as companies come back to use that cheap gas as a feedstock. And there are other manufacturing industries that could use natural gas for on-site heat and power to reduce their costs. Because we have a low price of natural gas that's decoupled from global markets, the United States has something like a 1 to 2 decade price advantage, I believe, in our manufacturing sector that makes me very optimistic about our cost competitiveness. So low price natural gas is good for manufacturing as a feedstock and as a source of heat and power and for efficiency overall. There's a great opportunity for the United States. That sort of ties in with distributed generation, using heat and power elsewhere. Distributed generation is most beneficial when waste heat is captured. We use about 100 quads of energy each year in the United States. A quad is a quadrillion BTU, or a billion million BTU, and a BTU is a British thermal unit. One British thermal unit has about 1 kitchen match worth of energy. So in the United States, we use about 100 billion million kitchen matches of energy per year. 55 quads of energy is released as waste heat to the atmosphere into the environment, and only 45 quads is actually useful. If we found a way to harvest waste heat, all our energy problems would be solved. And natural gas and some of the distributed systems, natural gas, are more compatible with capturing that waste heat than other larger centralized systems. We can use that heat for heating water, or for space heating, or for absorption chilling, to do air conditioning, or all sorts of other things. So this is one of those emerging opportunities, is distributed generation as a way to build resiliency in the grid and capture waste heat from the systems. And waste heat is one of the biggest opportunities. And there are policy levers available to policymakers. Next slide, please. Transportation is another opportunity. We use a lot of energy for transportation. Of the 100 quads we use per year, about 28%, or about 27 to 28 quads, is used just for transportation, and that's mostly from petroleum. We have a monopoly of fuels in transportation. 93% of our energy for transportation is just from petroleum. And we could switch from petroleum to natural gas in heavy-duty fleets and trains, some shipping, some other places. Eventually, light-duty vehicles, or really heavy-duty fleets, are the way to go. Natural gas has a lower carbon intensity than petroleum. It's about 30% lower in its emissions. So as we replace mile for mile diesel and natural gas, carbon emissions are reduced. The efficiency of the engines are about the same. There is a range issue in that the range, or the energy density of the natural gas, is lower, so you might not go as many miles in a tank of gas as you will with gasoline. But that's a technology we might be able to solve over time with new storage technologies. The cleanliness is a good factor, and it's also switching to a domestic fuel. So transportation, particularly for the heavy duty, or for the fleets that go home at night, like municipal fleets or garbage trucks, is a way to start the market growing for transportation. Eventually, it might make it to light duty vehicles. Next slide. The infrastructure is a big part of this. We're talking about end-use implementation, but you have to have a way to get the gas from the point of extraction all the way to the customers or consumers. And so we need to think about pipelines and storage systems, and we need to make sure those pipelines and storage systems do not leak. We also have to make sure that they operate in a very safe, robust way. So this is one of the areas to think about as policymakers grapple with natural gas, is what can we do to incentivize or foster a rebuild of the infrastructure or an extension of the infrastructure to make sure it is clean and safe and brings the benefits of natural gas to all the consumers who want it. Not everyone can get to it right now because the pipes don't go to their home. So there are new funding models and other approaches that can be addressed from the policy perspective. And then next slide, or I think, is that it? Okay, so good. So those are some of the end-use sector opportunities. It's, I guess, just to summarize again, it's a big step in the right direction if you care about secure energy and domestic energy and low-carbon energy, and as a way to achieve more efficiency and economic benefits for the consumers in all the different sectors we mentioned. So I'll stop there, and I think Eileen's going to come back up and kick us off with the CEO panel, where we're going to hear some additional perspectives on natural gas.